In the previous lessons, we discussed how the energy consumption of data centers has become a crucial aspect for environmental sustainability, especially in recent years with the growth of digital services and the resulting rise of cloud computing solutions, as well as the explosion of artificial intelligence applications in various fields. To understand and improve the energy efficiency of data centers, it is first necessary to have suitable tools for measuring energy consumption and the resulting environmental impact. Over the years, various metrics have been developed that make it possible to quantify the environmental impact and identify optimization strategies. Today, we will explore the main metrics used to assess energy efficiency and CO2 emissions in data centers, analyzing their meaning, calculation methods, and implications for sustainability. Power usage effectiveness, or PUE, is the most widely used metric for measuring the energy efficiency of a data center. It is calculated as the ratio between the total energy consumed by the data center and the energy actually used by IT devices such as servers, storage, and networks. PUE is a metric to be minimized within a data center, as a lower PUE indicates a more efficient data center, reducing the percentage of energy wasted on non-IT activities. An ideal PUE is equal to 1, which means that all the energy consumed is used for IT devices with no losses, due to cooling, lighting, or other support activities. However, in reality, PUE values vary greatly depending on the efficiency of individual data centers. Typical values range from 1.2, which is considered very efficient, to 2.5, which is considered inefficient. PUE was developed by the Green Grid Consortium in 2007 and has become a global standard recognized in various regulations. It is a simple metric, useful for comparing data centers, and effective for monitoring efficiency trends over time. Many initiatives aimed at improving data centers have focused on optimizing this metric. This has led to a rapid and significant decrease in the average PUE of data centers, which dropped from a value of 2.5 in 2007 to a value of 1.56 in 2024. The most efficient data centers are those of the major cloud providers such as Google Cloud, Amazon Web Services, and Microsoft Azure, which today boast very low PUE values between 1.10 and 1.18. However, PUE presents some important limitations. Inverse relationship with IT load reduction. As can be seen from the formula, considering only PUE as a metric for data center efficiency can lead to a paradox. In fact, if we make the IT component more efficient within the same infrastructure be using the servers more efficiently, the PUE can actually worsen. Lack of climate consideration. PUE does not explicitly take into account the location of data centers, favoring those built in cold areas where cooling requires less energy. Narrow focus. This metric does not take into account other relevant aspects of a data center's energy efficiency, such as efficient hardware usage, the percentage of server capacity utilization, or the environmental sustainability of the cooling systems used, which may be very energy efficient but can cause significant waste of natural resources. For example, evaporative cooling systems can significantly reduce a data center's PUE, but they result in high water waste. Despite the limitations highlighted, PUE remains one of the most widely used metrics for evaluating the energy efficiency of a data center. In recent years, however, this metric has been complemented by several others that help to compensate for its limitations. Today, we can identify more than 30 different metrics for evaluating the energy efficiency of a data center. In this lesson, we won't cover all the metrics, but only some of the most relevant and widely used ones. Nonetheless, let's try to classify the existing metrics. Metrics based on energy conservation. These metrics focus on optimizing energy use while also reducing electricity costs for consumers. Among these metrics, in addition to PUE, we find data center infrastructure efficiency and the energy reuse factor. Metrics based on eco-design. These metrics assess the level of sustainability in the design and management of data centers. They focus on reducing energy consumption, using low environmental impact materials, and utilizing renewable energy sources. Among these metrics, we find carbon usage effectiveness, water usage effectiveness, and finally, the green energy coefficient. Let's now briefly discuss the metrics mentioned to understand their meaning. Data center infrastructure energy efficiency is used to assess the energy efficiency of a data center and is the reciprocal of PUE. This metric is calculated by dividing the power used by IT equipment by the total energy consumption of the facility. While PUE helps organizations understand how efficiently a data center uses incoming energy, DCE measures how much of that energy is actually used by IT devices compared to the total available. This metric is usually expressed as a percentage. The higher its value, the greater the energy efficiency of the data center. The energy reuse factor is a metric that determines the amount of energy reused compared to the total energy consumed by a data center. For example, the waste heat produced by servers can be used to generate electricity or to heat other parts of the building. The closer the value is to 1.0, the more effectively the data center is able to reuse energy, improving its sustainability and reducing waste. The carbon usage effectiveness metric measures the carbon emissions associated with the energy used by a data center. It is calculated by dividing the total CO2 emissions generated by the data centers by the total energy consumption of the IT equipment. This metric provides an indication of the environmental impact of a data center, encouraging the use of renewable energy sources. Water usage effectiveness measures the water consumed by a data center in relation to the energy used, mainly for cooling. This parameter is crucial in areas with water scarcity, as high water consumption increases the environmental footprint. It is possible to reduce water usage effectiveness by optimizing cooling strategies, for example by adopting air-based systems or recycling the water used. The green energy coefficient measures how much of the energy consumed by a data center comes from renewable sources. This metric is calculated by dividing the amount of renewable energy used by the total energy consumption of the facility. The closer the GEC value is to 1.0, the lower its environmental impact. Energy and environmental metrics are essential for assessing the efficiency and sustainability of data centers by monitoring energy consumption, CO2 emissions, and water usage. However, measuring these metrics is not simple, and there is often a lack of uniform standards for comparing different facilities. With the growing demand for digital services, it is essential to adopt innovative solutions to reduce environmental impact and objective that can only be achieved through accurate measurement. In the upcoming lessons, we will explore strategies to optimize these metrics and improve the sustainability of data centers.